Welcome back, polar bears and polar cubs. We're going to talk about counting atoms and then a little bit about average atomic mass. So let's get started. First thing that we need to know is the atomic number. This we give the symbol of Z. Okay. But that symbol is really more so because we want you to be able to have formulas. Okay, this tells us the number of protons in the nucleus. They are in the nucleus. Okay, they're in the nucleus. Okay, and then as you go on the periodic table, it is increasing atomic number. Okay, so as protons increase, so do you move from left to right on the periodic table. Most of the elements that we're going to talk about are electrically neutral. However, when they're not, we'll talk about that in a little bit. When they're electrically neutral, you have this. Okay, so you have protons equaling electrons. On our periodic table, it is the top left corner that would be Z. Okay. For isotopes, there's these things called isotopes. So what is an isotope? Well, an isotope is the same element, however, it has a different mass to it. So when you have a different mass, you have different neutrons, and this is where the neutron came about. So protons will be the same, so will electrons, but the neutrons are where we will be different. Okay. When they discovered isotopes, it is then that we realized that Dalton's second postulate was incorrect. Okay, because he said that there were all atoms of the same element would look the same. Here are the three isotopes of hydrogen. So you have one that is just a proton and an electron, one's a proton, a neutron, and an electron, and then one has a proton and two neutrons and an electron. Now, the mass number, okay, is the number of protons and neutrons added up. Electrons have a very small mass, so we really don't care to add them in. Think about it this way. It would be like having 1,000,000 pounds of something and missing 1,000,000 pounds of sand, and someone takes a couple specks of sand. It's not that big of a deal. It probably didn't even move the scale, and that's how electrons are. So your mass number is going to be protons plus neutrons. So this is going to help us to determine the number of neutrons because you're always going to have the number of protons. So on our periodic table, okay, this is set up just like our periodic table would be. You have Z right here, and you have A right here. Okay, and this is the mass number, which is protons plus neutrons, and then you have the atomic number. So, can we have an equation in order to do that? Yes, we can. Let's get rid of that for a second. Ooh. Okay, and it is A minus Z, where A stands for the mass number, Z stands for the atomic number, and that will give you neutrons. Now, notice how we have this like 0 up here. What that 0 is the charge. Notice how protons have the plus because they're positively charged. The 0 would be a neutral charge, and that's how they got their name, neutron. So if we have an element that has an atomic number of 8 and is known to be electrically neutral, how many protons and electrons do we have? Well, the key part of this is electrically neutral. Atomic number of 8. Well, atomic number is the number of protons, so I know that I have 8 protons. Well, if I have 8 positives and I need to be electrically neutral, then I must have 8 negatives. All right, I'm going to give you 3 seconds, or count down from 3. Go ahead and find the element on the periodic table that has 3 protons. 3, 2, and 1. Hopefully you found lithium. So how are isotopes written? Well, they can be written 2 different ways. They can be written the nuclear way, which a lot of times what happens is the atomic number is not written there, but you just have the mass number there. Okay, those two like the mass number in the upper left-hand corner. That would be the nuclear symbol way. However, you have the hyphen notation, which is more common for us to use, and this would be the name with a hyphen and then the mass number. Atomic number is not as important to show because it's always the same atomic number. Here are just some more examples of isotopes. So carbon has 3, hydrogen has 3, lithium has 3, oxygen has a couple more than just 2. So how do ions form? So now that we got our atoms down, and we know kind of what goes into an atom, how do ions form? Well, ions form when these protons and these electrons are not equal. If it's neutral, they're equal. But ions, you need to have different numbers. So in order to be a cation, you have to lose electrons, meaning a cation has more protons. So protons are greater than electrons. And then for an anion, you have protons are less than electrons. Now, depending on what charge you need to get, depends on how many more protons you need to have than electrons and how many more electrons you need to have protons. What I will tell you is, do not, I'll put don't, change protons. So don't change the number of protons. Protons, if you change them, you're changing the identity. And we can't change that. We're talking about oxygen. So we can't change the fact that it has so many protons. The only thing you can change are electrons. Those are the only thing that changes. So, in order to be a positive ion, aka a cation, you have to have less electrons than protons. So, for example, this one, you have an atomic number of 11. So, you have 11 protons. And that means in order to have a +1 charge, you can only have 10 electrons. So, you have one more positive than you do negative. An example of an anion is oxygen. So with oxygen, for it to have a -2 charge is what happens right here. You can see right there. Is you now have 8 protons, but you need to have 10 electrons. And that would give you a -2 charge. So you're going to get a little bit of a chart like this that you're going to fill in, but you're going to fill in everything, okay? A lot of it, I'm just going to give you the name or the symbol, and then you'll fill in the rest. So with fluorine right now, you have 9 protons and 9 electrons. That means that it has no net charge, which makes it an atom, not an ion. Fluoride has 9 protons and 10 electrons. Therefore, it has a -1 charge, making it an anion, which then it is an ion. Sodium, if they're equal protons and electrons, they have no charge, and they are no ion. This one has 11 protons and 10 electrons, therefore it is a cation with a +1 charge and a check mark. Here are the 3 isotopes of hydrogen. So, or 3 common charges that you might have. So hydrogen can be neutral if it has a proton and an electron. If it has no electron, it can have a +1 charge. And if it has a -1 charge, it has 2 electrons. Now, before we get started in the relative atomic mass, I want to encourage you, okay, to go to see the back of the periodic table. So on the back of your periodic table, there are formulas to help you find out the number of neutrons and the number of protons, or the mass number. So how did we get relative atomic mass? Well, we got it due to the fact that if you're dealing with an atom, it has a really, really small mass for one atom. As you can see, based off of carbon, 1.99 times 10 to the -23rd grams. So there should be 22 zeros in front of that one. Okay, it's really tiny. So they came up with a mass. And carbon-12, they gave it 12 atoms with the atomic mass of 12 AAM. Okay. That was just a atomic mass units. So they kind of came up with their own units, which then eventually became grams. Okay. So with average atomic mass, what average atomic mass is, it takes into consideration the isotopes, but it doesn't just take into consideration the isotopes like you guys with averages, where it takes the masses and it adds it up. Not all of them are there on an equal basis. Okay, so what do I mean by an equal basis? Boron, for example, has 2 isotopes. Okay, and the first one is there at about 20%, and the other one is there at about 80%. So you have to take into consideration the percentages. It's kind of like our grades for your class. So at 80.2%, you then multiply that by the average atomic mass of that, or average mass units, and then you take the 19.8% and you multiply it by its average mass units. Now, when you do that, you get your answers. When you add them up, you actually will get the average atomic mass of all the isotopes. And that's what we're asking you to be able to do. Okay. So the first things that you need to do, you need to take your percentages and you convert them back to decimals. So we need percentages to decimal form. Now you're going to take the relative abundance, which is what those percentages becoming decimals does, and you're going to multiply by mass. We're going to add them up. We're going to go to the hundredths place, and your units will always be AMU, and then you'll put the element that you're dealing with. Okay. Now, we're going to use this information. So I'm going to go ahead and work it right here. So you're going to take that point, you're going to move the decimal place 2 places over to convert them. So you'll take 0.9 890 times. Now that is 12, carbon 12. So times 12. Now, once you get that, you're going to add that answer to the answer of 0.0110 times 13. And when you add that up, now mind you, that's 13.00335. You should get 12.01 or something around that. Okay. So here's all that work that I was showing you. Okay. So you take that, you multiply it, take that, multiply it. You get these answers. You then add those up. You're going to get 12.011. Going to round it to the hundredths place, and you get carbon equals 12.01 AMU. Now, for us, you would type it in as 12.01 AMUC, or carbon. And finally, if you were to have to round atomic masses, like you might look at your periodic table and be like, hey, Mr. Madej, it's already at the hundredths place. That's because we went through and we went ahead and rounded for you guys. So like, notice how this has a 1. Well, behind the 1 is a 1, so I don't round anything. Oxygen, behind the 9 is a 9. So that 9 rounds it up, which then actually rounds the 9 in front of it up and makes it 16.00. Potassium, the 8 rounds the 9 up, putting a 1 there, so you get 39.10. All right, well, that was the counting atoms portion of chapter 3. Now, when you are starting to do that, remember, atomic mass is determined, okay? You need, when you're using atomic mass and you're dealing with neutrons, it's not an exact number of neutrons. So you're going to round them up, and on our worksheet, you're going to put them in parentheses. Whereas if it is a mass number, it's an isotope, and therefore it is a known number of neutrons, so there will be no parentheses. So the other thing that this is telling you is that you can't have both. If you have an atomic mass, you're going to put an X in for mass number. If you have a mass number, you'll put an X in for atomic mass. And those are just some of the hints that will be useful as you go through counting atoms worksheets. All right, good luck, and let me know if you have any questions.